But yeah, today is all about building the best products at the best price. And of course, the focus is on containers and Kubernetes, which has become an important part of modern cloud architecture. So I thought I'd run through a quick case study. And this is a mobile application use case built on our public cloud using Kubernetes. And it's a social and community mobile app with about 10,000 average daily users and about 50,000 monthly users. They've got a lot of multimedia content that's stored in object storage, and the smartphone itself is accessed via API. They're using 12 compute instances, and there's about 10 terabytes of object storage and 20 terabytes of external traffic. And because our public cloud is built on OpenStack, they enjoy the benefits of open standards, one of which is technology freedom and interoperability. But yeah, let's also look quickly at a cost comparison with our competitors using cloudeasier.com that we listed on, which is a useful tool that you can use as well. And this comparison is based on the monthly price for a year period. And you can see there's significant cost savings with OVHcloud. And this is driven by our great price to performance ratio. Also the fact that we charge minimal or no bandwidth costs, as you can see from the pie charts there. And this means that there's more price transparency for you as a user. And just moving on to the next slide, over and above these benefits, with OVHcloud, you can also access global scalability with our 32 global data centers. As a European cloud leader, we can also offer you data sovereignty, which gives your clients peace of mind in terms of their data. And on that point, we actually have a workshop on the 25th of March on data sovereignty, so look out for the comms around that. And then as a startup, the best way to access all these benefits is through our startup program. And here, in addition to the free credits and the solution architecture support that we offer, we also now have a mentoring program and also new access to market opportunities. So look out for these opportunities as well. But yeah, I think we've got a full house now. And so enough about OVHcloud. Let's move over to Horatio to talk about containers. Over to you, Horatio.
Okay, thank you very, very much, Philip. So we are here to talk about containers and Kubernetes and why Kubernetes and what about other alternative solutions. I will try to do everything in under 1 hour. So let's begin. Well, as you can maybe hear, I am a Spaniard living in France, so my English accent is a mess. Sorry about that, really sorry. I work at OVHcloud as the development leader, so developer evangelism, developer advocacy, technical communication, and all that. And well, Philip has already done an introduction about OVHcloud. I am not going to add anything besides we are one of the top 10 cloud providers and hosting providers in the world. We have a huge catalog of products. So next time you have an infrastructure to build, an application to deploy, hey, have a look to our site. I think you will be surprised of the products and the prices. So let's talk about container, and let's talk about why we need something like Kubernetes. Because when you have one container, everything is sample. When you have 100 containers, then if you want to administer that by hand, you have a problem. So if, like me, if you are getting old, you will maybe remember when we deployed everything on physical computers, on physical machines with the operative system on it, and then we deployed our application, and it was really resilient, reliable, but it was really not agile. When you needed some new instance, you needed to get some new servers to put them in rack, to install an operative system, and then your application. So when virtualization arrived, it is not a surprise that everybody began to do it hey, you could do some abstraction of the physical part. You have an hypervisor, and then you could create really easily virtual computers on the fly. And then you installed your application over there. But since some years, 5, 7 years, many people have begun to do containers. Why? What's the interest? Well, let's have a look at what is the difference between containers and virtual machines. So the biggest difference is in virtual machines, you are installing on your physical infrastructure an hypervisor, and over this hypervisor, you are installing fully independent virtual computers, everyone with their operative systems, their binaries and libraries, and their applications. It's very well isolated, but the guest operative system is 99% the same for all the virtual machines in your hypervisor. So at the right, you can see the container approach. You are installing your physical computer and a normal operative system on it, and on this operative system, you are installing a container engine, usually Docker, because it is the most well known, but any container engine. And on this container engine, you aren't deploying an operative system. You're only deploying the binaries and libraries that your application needs. So you can have something that is lighter than a virtual machine, but you get similar, almost identical independence between all of them. And so you can get something lighter, less expensive. You can use really all the performance of all the efficiency of your underlying physical computer. But the principal reason why we are using containers is because it allows us to create a different paradigm. Let me explain. With containers, you are defining for every application you are running, you are creating some description file, Docker file. They are like instructions in order to create the container that will be run on the container engine. So with this Docker file, you are going to build a Docker image. The Docker image is like the technical blueprint for the container. And every time you want to launch a new container for the application, you take the image, you run it, and it will deploy a container. And that means that developers' life is way easier. And for me, that's the real reason why everybody is using them now. Let me explain. Let's say you have to install something like a WordPress, and all the WordPress with the WordPress engine, the PHP engine, and a SQL database like MariaDB or MySQL. Before containers, the developer in their computer, they needed to install a PHP engine, a web server, which one? Apache, Nginx, and then over that, they needed to get a WordPress distribution, install it, getting a MariaDB version, installing it in their computer, usually a Windows or a Mac, and do their coding. And when everything was ready, they sent the code to the deployment to the sysadmin guy, and the sysadmin person then had to run the code on the production stack. That means different operative system, usually a Linux. That means different version of the PHP engine because they are using Apache and the developer has used Nginx. Maybe different database. You are using maybe MySQL, the developer is using MariaDB, or a different version of the same database, and then nothing works. So the sysadmin calls the developer, hey, it doesn't work. Okay, but it works on my computer, but it doesn't work in production. Not my problem. That kind of discussion was a real problem. With containers, everything is easier. Developers and sysadmin will run exactly the same image. The developer will go to look for a WordPress and MariaDB image and will run that on their laptop over the container engine. And when everything is done, he will create a new image and send it to the sysadmin person. And the sysadmin will take the image and will run it on their production Linux, but on the container engine. The image will be running on the same platform, a container engine. So everything will be easier. No more, it works in my computer, it doesn't work in the production problem. And that's a big win. So developers' life is easier with containers. But what about sysadmin? Well, maybe it works for a developer, but if you are doing an production WordPress, you know you also need a load balancer, you will need to duplicate or create several instances of the WordPress for high availability. You will need to duplicate the database, you will need to add external volume to store the data of the database. So, okay, it will run on containers, and no more it works in my computer problem. But as a sysadmin, you still have complexity, the same complexity than before. The same. Well, the bad news is that not really, because when containers, another trend that arrived was microservices. Microservices mean that before you have one big monolithic application, now you are going to cut this application in 20, 30 micro applications. For the developers, it's way easier. They are reducing complexity. They don't need to understand every detail of the huge application anymore. They can center themselves in their respective micro application. But for the sysadmin, for the DevOps person, that means that they will have 30, 20, 40 containers to deploy for a single application. And these containers need to speak one with another, and you need to see that the network link is up, that the attached volume is there, that you need to keep all that working. So the complexity has exploded with microservices and containers for the sysadmin guy. And that's the reason why you need something to help you to tame the complexity. The first thing, or one of the first things that everybody used was Docker Compose. Docker Compose is an open source tool by the Docker team that allows you to describe multi-container application. So let's say your application has 10 containers. You can create a global description file, a global YAML file, docker-compose.yaml, and then you are describing, hey, my application has 10 services. The first services is this Docker file. The second services is this Docker image. And I am going to need this volume, and this volume. And using Docker Compose, you are going to directly deploy on your container engine the different elements of your multi-container application. Docker Compose is a good solution if you want to run your application only in one container engine, in one virtual machine. You aren't going to be able to do efficiently a cluster, to manage high availability, to manage scaling. It's mostly static and mostly simply a tool to help you to deploy several containers and attached volume at a time. But it helps in some cases. It's a good tool. Then we have Docker Swarm. Docker Swarm was the Docker response to the complexity problem. The idea is, okay, so now we are going to get a whole set of virtual machines with Docker container engine, a whole set of Docker hosts, and put them in a cluster with some manager node and worker node. And it allows you to have a cluster in which you can use Docker Compose, for example, or something analogous to that to deploy your application. it is fully Docker-centered. I mean, it uses Docker APIs. It has the same limitations that Docker, but if you are used to Docker, it could be a nice solution. So why, if we have something like Docker Swarm, why is everybody talking about Kubernetes? Because Kubernetes, it goes further, a lot further. The idea is Kubernetes is a full orchestrator. You aren't simply defining a cluster. You are defining a cluster with a full set of networking function, controller, extensibility, security. You are defining a whole way to deploy, manage, and follow distributed architectures in production. So Docker Swarm is a solution to deploy several containers in several Docker hosts. Kubernetes is a solution to a bigger, more general problem, having distributed systems resilient with self-healing. For example, if we lost a node or some containers, everything will be taken care of by Kubernetes. Something extensible, you will be able to tune it to your specific needs. Something why more complex too, because it addressed a more complex need. So let me continue. I think I have a question over there. Can I give an example of multi-container application? Yeah, for example, the WordPress I told before. In order to deploy a WordPress, you will need a WordPress image and a database image, MySQL, for example. And the database image will need to have an external volume to put the data. So in order to deploy a WordPress with containers, you will need to have two Docker images and an external volume and deploying that by hand. Using Docker Compose, you can create a Docker Compose YAML file saying, hey, my application is two services, WordPress and MySQL. WordPress, this image. MySQL, this image. And an attached volume, this volume with this capacity. And you are deploying in only one command your complete WordPress architecture. That is one example. So let's try to dive deeper in our Kubernetes. I'm going to try to keep the question pad open. So Kubernetes architecture, it can be, we can simplify it is saying you have nodes in your cluster, you have instance, virtual machine instance, and this instance will be divided in master instance and worker nodes. The master nodes, they are used to manage Kubernetes, the deployment, the self-healing, the monitoring, the extensibility, all that. They are the intelligence of the cluster. And the worker nodes are the nodes where you are going to deploy your application, your containers. If we go deeper in details, in every node, you are going to have some technical bricks like kubelet or kubeproxy in order to communicate with the cluster and verify that everything is okay. And you are going to have pods. Hey, why pods and not directly containers? Because sometimes you want to deploy a container with an attached container that modified its behavior. For example, let's say you are deploying your application and later you decide, hey, it will be nice if all the internal communication in my app were encrypted because we want to add this security. In a non-Kubernetes world, you will need to add the encryption part to every one of your containers, modify them, create a new image, and deploy the new image. With Kubernetes, as you are deploying pods and you can declare several containers in a pod, you can attach a container that will listen the outbound communication of your main container and encrypt them. You can use the encryption as a side feature. In Kubernetes lingo, we call that a sidecar. We can add sidecars for encryption, for logging, for monitoring, for almost any technical function without having to touch to modify the code of the main image. So we are delegating this part and we are creating a separation of concerns that reduce the complexity. In the top part, you have some elements of the master, the API server. It is the heart of the Kubernetes cluster. In Kubernetes, all the functionality are addressed using APIs, and it's very extensible. You can create your new APIs in the API server. The scheduler will see that the architecture that you have asked for is deployed. So it's a critical part of the deployment in the self-healing. There are some controller manager to verify that everything is right, that you have all the resources you need. And the etcd, it is the brain of the cluster. It is the only stateful part of the master nodes. So it's where you keep track of all the elements you have deployed, their state, and all that. But the great difference of Kubernetes is that it works in a desired state mode. I mean, you aren't going to describe the details of all the architectures you want to deploy. You are simply defining what you want. Hey, I want this application with this pod as front end, and I want this pod to have always 2 instances of the pod running, but if we have heavy load, we can go up until 10 instances. And we want this backend with 3 instances by default, and we can go up until 10. And I need this external volume and this one, and I want you to verify all that. If a pod doesn't answer anymore, you are going to kill it and respawn it, and you declare in a YAML file what you want, and it is going to create a whole series of Kubernetes objects, pod, deployment, services, sidecar, replica set, and all that. I think I have a question. Okay, I go back to Docker Swarm. Are containers in Docker Swarm similar or just duplicated? Well, it depends. In Docker Swarm, you are going to define a bit like in Docker Compose. For this application, I have these services, and this service I want to have a copy in every worker node on my Docker Swarm, only one copy, several copies. You can define how many instances. The autoscaling works somewhere similar to Kubernetes. I will go back to the difference between them later. And you have a good deal of flexibility or what do you deploy and how many instances of every item you deploy you are deploying. So let's go back to Kubernetes, the state management. You describe your app and Kubernetes creates everything and monitors everything. From a sysadmin point of view, that's a dream feature. If we lost one pod, one node, Kubernetes is going to repair all that and be sure that your system is running. And you will only need to do something manual if the problem is really, really big. So let's compare Kubernetes and Docker Swarm. Let's fight. Well, it's not really a fight. For me, they aren't equivalent tools. They are similar, but for very different use case. Let me try to explain. For example, as I told you, in Kubernetes, you are defining everything using Kubernetes YAML, Kubernetes APIs, you are defining complex objects, and you can describe easily very complex architectures. I mean, not only a WordPress with 2 containers, I mean a full Apache Pulsar clusters that calls to an Hadoop cluster and tens of microservice application with some very concrete network rules and all that. You can declare complex architectures. Docker Swarm is fully centered around Docker. You can deploy containers and you can deploy multi-containers, like with Docker Compose. And everything is defined in Docker files in Docker API. It's a bit easier to begin with, but you have limits. You arrive rather quickly to some limits. Scalability, something similar. Kubernetes is built for distributed systems. So scalability, both horizontal and vertical, is a key feature. That means also it is more complicated. There are a lot of controls and checks to be sure that we can scale, we have enough place, everything is running smooth. So deployment and scale, it's somewhere more complicated and slower. At the right, we have Docker Swarm with a sample architecture, a sample model, easier, a bit faster, but without all these guarantees and all these distributed system focus that you could have in a Kubernetes. High availability. Yeah, Kubernetes is really strong on that. There is the self-healing part I have talked about. There is load balancing and the dynamic pod distribution. You can replicate everything in the master node, so you can have also high availability in the master. The brain of the cluster, the etcd, can be deployed outside the cluster in their own cluster to be sure that you have never problem with that. So it is really a strong, high availability capacity, adding some complexity. Docker Swarm, it has high availability, maybe not so strong, but it is easier. Networking, something similar, I am not going. So you have a flat network model, very flexible network policies. You can deploy different network routing for the service and the pod. You have really all in your hands to describe the network as you want. In Docker Swarm, you have something easier, but also more limited. You've seen the trend now. We can talk about other advantages. For me, this one are really critical too. Kubernetes has a huge community, thousands of contributors, people following every release. You have many companies behind them, from big one, GAFA and company, to small companies. You have a whole open source foundation behind it, the CNCF, and you have a very flexible, customizable thing. You can tune your Kubernetes as you want. In the Drawbacks side, the learning curve is more complicated, and you are going to learn new tooling in order to do it. With Docker Swarm, it is easier, it is more lightweight, it is fully integrated in Docker tools, the community is small, there is only Docker as big company behind, and the fault tolerance, the high availability is not that strong. So for me, you can use Docker Swarm to test, to deploy some application, but I wouldn't use it to deploying critical things, complex architectures, or simply a multi-application setup. For me, if you are deploying a whole ecosystem of applications or complex architectures, or simply things where you want to be sure you have fault tolerance, high availability, and a good horizontal and vertical scaling, you should go with Kubernetes. So for me, they aren't the same kind of tools. Docker Swarm is a tool to go further with Docker without learning new things. Kubernetes is a world ecosystem to the deploying distributed systems, a bit more complicated, but it is worth it. When you learn Kubernetes, you will see that you can create infrastructures that are way more reliable and efficient.
Actually, there's a question there that I think might be worth answering.
So Okay, the question, as startups are often stripped of resources, limited number of people, you need to understand Kubernetes to troubleshoot problem. Yeah, that's a question I am going to answer in a few minutes because, yeah, using Kubernetes is not very complicated. Administering, having a Kubernetes in production is complicated. I am going to go back to that, but yes, the solution is using and manage Kubernetes. You have all the power of using Kubernetes without the hassle of administering Kubernetes. I will go back to that later. Yeah. So another nice feature is, as everything is declarative, you are describing your world environment in some text files. That means you can put them in a Git server in order to version it, and you also can create clones or your infrastructure really easily. For example, developer environments, staging, multi-cluster, multi-cloud. So when you have one Kubernetes cluster working, you can easily clone that. And that's a nice feature for many use cases, especially if you want to have some staging or developer environments that are a mirror of the production. Another thing, a big strength of Kubernetes is that it's really easy to begin with. I mean, you can run a whole Kubernetes in your laptop using something called Minikube, an official Kubernetes tool. You can install it in your laptop and you have, wow, a whole Kubernetes running on it, and in a few minutes, and you can begin to learn Kubernetes with it, to deploy complex things. Okay, it is still, sorry about that, I am looking for my mouse. It is still your computer. So if you are deploying a lot of things, it's going to be slow and your computer is going to get hot, but you can learn easily Kubernetes with it. And that's a big strength. Everybody can learn the basics of Kubernetes in a few hours, but that's also a problem because usually you do that tonight and tomorrow you will go back to work and say, hey, I have deployed a distributed system in my Kubernetes. So now we can go in production with Kubernetes, can't we? And that's the problem. Why? Because, as I told you before, there is a big difference between using Kubernetes, deploying something in Kubernetes, and having a production-ready Kubernetes. As you see, Minikube, everybody can learn it quickly. So most tutorial and information you will have in the net about Kubernetes will stop right after that. Hey, I have deployed my Pulsar cluster in Kubernetes. Cool. And now, well, the next step will be deploying your own Kubernetes. You will need some technical expertise. Maybe you will spend 1-2 evenings if you aren't using to Linux tools, but you will be able to deploy it. It is the orange flag. But in order to go into production, you will need to arrive to the red flag, and everything in the path, they are traps, lot of problems. So I'm going to simply list some of these problems, and I will go back to why, in my opinion, many companies should use a managed solution. Well, let's talk about the travel to production. And on does not simply deploy Kubernetes in production. Yeah. Because as I told you, it is great for developers, but it comes with a price, the complexity of deploying and administering it. Why? Because, as I told you, Kubernetes is almost magical. You are describing your architecture and they are implementing it. So how does Kubernetes do it? By adding abstraction layer over abstraction layer over abstraction layer. At the top, you are going to say, hey, I want this application deployed. At the bottom, you will have containers, networking, IP tables, and all those low-level gritty things. When you have a problem, you need to understand this abstraction layer. Hey, it isn't deploying. Why? You will need to dig the abstraction layer down in order to find what is the real problem. And that can be complicated. and there is a learning curve for that. Also, networking. Networking is complicated, let's say, in Kubernetes. There are many levels of networking. There are a lot of networking plugins. Not all of them work in the same way. There are many concepts, EPAM, IP tables, routing. You have also Kubernetes networking concept like cluster IP, node port, ingress, load balancing. And that means that at any moment you can have a network problem if you haven't configured your network and your Kubernetes right. And debugging this network problem is complicated if your network engineers don't understand Kubernetes. The storage, Kubernetes at the beginning was meant to be stateless, but rather soon people began to put data on it. So they added some concepts for persistent volumes, external volumes, but by default, they are storage for files using NFS. So it isn't suited for databases, for backup and storage of things like databases or search index on all that. So it will work very well in development, but if you want to use it in production, you need to have somebody with you that understand the low-level problems of what is the protocol you are using for your persistent volume, what is the backup procedure, and all that. So please, if you have some Kubernetes in development before going in production, if you are using persistent storage, please have a look at the potential problems. The etcd I told before, hey, it is the brain of the cluster. Yeah, it also means that if you lose it, you are going to have a problem because your cluster is going to forget everything. It will remember what are you deploying and why. And in a normal Kubernetes, when you deploy it, this etcd is a small virtual machine without any resilience or redundancy. So if you are serious about going in production with Kubernetes, you need to have an external etcd cluster with 3 or ideally 5 physical nodes with all the backup for that and all that. Security, that's really funny because everybody who does Kubernetes say, hey, it is a problem, but it is a problem by construction, by decision. The problem is that Kubernetes has everything you need to securize it. But it's like that castle in the drawing. Everything is wide open by default. So you have all the elements to securize your cluster. By default, none is active. Why? Because there is the philosophy that for similar needs, for example, for dealing with a money application, you could have different security requirements. It is not the same for a banking application that for a small service inside a company. So by default, they decided, okay, so different security needs, we don't choose, we put everything off, and if somebody needs security, they can do it. But many people who go in production forget that and don't securize their cluster. And as Kubernetes is very popular, it's a great target for all kind of hacking. So you need to define and securize your security practice according to your needs. That means closing all open access you don't need, defining roles, defining security groups, defining what access are really needed, defining network policies, what pod can talk with other pod, separating sensitive workloads, and especially keeping everything up to date. Every week, every 2 weeks, they are patches that need to be applied, and if you don't apply it, you are leaving your cluster open to potential problems. And it doesn't happen only to newbie people. Tesla, we are talking about one of the biggest and better technical users. Tesla has one Kubernetes cluster that got hacked because of an out-of-date plugin, I think, and they got hacked for several weeks before they noticing. and they were lucky. It was hacked by somebody who wanted to mine Bitcoin, not by a competitor. And if it could happen to Tesla, it can happen to me, to you, to everybody. So even if you do all the security good practice, you need to plan for disaster recovery, backup, restore, monitoring of possible problems, and all that. Kubernetes is very extensible. That can help you in your first cluster, but also add some complexity. They are things like Helm is a package manager for Kubernetes, so you can deploy very complex Kubernetes architecture with only one command. That means you can do things like upgrading old architecture or downgrading, doing a rollback or sharing architectures in a sample command. And you have Helm chart for most open source projects. So a good idea is to use the Helm chart for the project that have it and creating your own for your own architectures. Istio is a great plugin when you are beginning, even if later it's a bit overkill, but when you are beginning, you are going to have to add a lot of security feature in an easy way. Rolling upgrades, A/B testing, canary testing, input traffic securitization, input control, monitoring, a full dashboard to monitor everything, encryption between the pods, all that is doing in a transparent way by Istio. You need to configure it, you need to learn to use it, but it's a very good idea where you are beginning with Kubernetes, and there are really good documentation and tutorials about Istio. So service discovery, traffic control. Sorry, I am trying to go faster because I want to have time to answer all your questions after that. Routing and load balancing, rolling upgrades, A/B testing, monitoring, and a nice dashboard, and all that. Velero is a key piece of the ecosystem right now because it allows you to easily backup your Kubernetes. As I told you, Kubernetes has a decided state management philosophy where you are declaring the state, you are declaring what you want, the target architecture, but you are also, so it means it can be replicated, it can be backuped, but a cluster, it isn't only the individual components are their relationship, it is also the data. So how do you backup the data in Kubernetes? Let's say you have a database, a MariaDB, and the database is using a persistent volume claim, PVC in Kubernetes lingo, that is a logical mapping between your pod and an external storage, and this external storage is defined in Kubernetes term by a persistent volume. And if you need to do a backup, you need to backup in all the side in the persistent volume, but also associate the persistent volume with the state of the persistent volume claim in order to be able to restore in an easy way. If you only backup the data, your Kubernetes it isn't going to be able to use it. So that's a problem. How do you can easily backup your Kubernetes cluster? That's the role of Velero. Velero allows you to backup your cluster in any S3 protocol store. So you can use any commercial or open source based in Swift S3 protocol, and you can backup the configuration, but also the data of your cluster, doing really a snapshot of that and being able to restore it at any moment. And as any backup solution, you can do fully backup or partial backup. You can schedule backup. You have some backup hooks in order to be able to maybe stop some database before the backup, or doing some cleaning, some compacting before or after backup, or anything you need. It's a full backup and restoring solution for Kubernetes. And if you are going in production, please have a look at it. In conclusion, one more thing. Kubernetes is really easy to begin with. You have Minikube, you have other interesting projects like K3 is. Have a look at that, it's really funny. You can deploy the cluster in a small Raspberry Pi servers. So it's really easy to begin. It's really easy to get proficient on it. It's very powerful. and if used correctly, it's going to be to make your developers and DevOps and sysadmin lives easier. But it has a price, operating it. There are many potential problems to deal with before putting a Kubernetes in production. Security, deployment, monitoring, backups. But that also means that there are different kind of roles around Kubernetes. There is developer. They only need to be able to deploy their application, describe their application in Kubernetes way and deploying them. It is really easy for them. There is the cluster administrator that is going to do all the, hey, I need to deploy a Pulsar cluster in my Kubernetes. Hey, I need to create some namespace. It's a really Kubernetes use focus role. And yeah, almost any sysadmin or DevOps should be able to do it with after a few training. The real complex role for me is the Kubernetes operator, the people responsible of installing, keeping patched, in securizing Kubernetes, defining the network, defining all the, dealing with all those problems we have seen. And for me, this role is really hard. The learning curve is really steep, but most companies, especially startups, they don't need that role because it is some full-time person or several full-time people needed for that with a lot of training. Hey, for most startups, it makes sense to having somebody that understands how to use Kubernetes and having the developers who understand how to put their application in containers and those containers in Kubernetes. And that's all. Why? Because you, in a startup, you aren't building your own servers. You aren't installing your own operating systems. Kubernetes is like that. It's like a distributed operating systems if you want. So it isn't your job to install, to maintain, to patch it. You can use any managed Kubernetes solution. And the good news is that all of them are certified. The CNCF Foundation certifies managed Kubernetes. That means that a solution that you install in your Kubernetes in development at home, it is going to work in production in any managed Kubernetes, our own or any other competitors. Of course, I think ours is one of the best, and I know it because I was there where the team created, and we have been very transparent of how we have done it. You have a lot of information in our blog and elsewhere if you want to know how we have done everything and why. So I know it works really well. So you want to try it? Hey, you can contact Philip after that, or you can contact directly me, and I think we can get you some vouchers in order to try it. But remember, you are a startup, you don't need to install your Kubernetes. If your business isn't around Kubernetes, please don't lose your time, your focus, your energy in learning to install, operate, patch, securize your Kubernetes. Get a managed Kubernetes, our own, for example, and simply use Kubernetes. Get all the benefits of the technology without the drawbacks. And for me, that's all. Thank you very much.
Thanks, Horatio.
So I think there are some questions trying to get them. Let me try to maximize the question panel. Donc, this is the first.
I'm also going to unmute everybody now. That means that if you want to ask a question, you can raise your hand, and then we'll call you out, and then you can unmute yourself and ask your question. But yeah, in the meantime, Horatio, you can look through those questions there and start with those ones.
Okay, let's talk about that. What's the role of the cluster admin if you do of the heavy lifting? Yeah, we are, when I manage Kubernetes, we are doing the install, we are doing the patching, we are doing the networking. The cluster administrator is going to define how you are going to use this cluster. Hey, we are going to use different namespace for different application. Hey, we are going to deploy some common infrastructure for all the application, service bus, some general database. You are defining you are defining the common elements and the global architecture, and you are helping developers to put the application in Kubernetes. You need to know how do you deploy things in Kubernetes, how you create Helm chart for your own infrastructure, how you create namespaces, for example, and what's the idea behind that. You need to know how to use Kubernetes. Why? Because you don't want that every developer becomes an expert on Kubernetes. It makes sense to have somebody that is more an expert of Kubernetes. It makes sense if your company already have some DevOps profile. If your company, they are only developers, yeah, you can simply make sure that every developer have a basic learning and onboarding on Kubernetes, and you could do it without admin, but it makes things easier. So who writes the YAML for Kubernetes? Well, in many cases, it will be the Kubernetes administrator, but very quickly, most developers are going to be able to understand Kubernetes, at least to be able to write the YAML for their application, and the administrator is going to look at it, look if they can mutualize some services or something like that, but it's not he or she it isn't going to write every line of a YAML, because developers are getting proficient with that really quickly.
We've got a hand up right here from Olga. Olga, do you want to unmute yourself and share your question? Yeah, you will have to unmute yourself before we can hear you.
If you prefer, you can write your question too, as you want.
You should be able to unmute yourself, but if you're having any trouble,
right. I have a question. How I could use Istio at OVH and integrate that?
Yeah, you have a managed Kubernetes with OVHcloud. You can simply install Istio. We have a tutorial for that. You install Istio as you would install any other Kubernetes package. The idea is Kubernetes is really modular. So in a base cluster, you can install anything in order to tune your cluster to your needs. So Kubernetes, so Istio, you use the same standard kube control tool to install Istio, and when you have Istio installed, you can easily configure it. We have a tutorial on that in our website, and there are lots and lots of tutorial about Istio. So take a cluster, one single command, and your Istio will be deployed.
Okay.
So we've got another hand. We've got another hand up from Jonas. Thanks, Jonas.
Okay, so my question is, I was the one who was asking about the complexities of Kubernetes. For example, we're a small startup, 2 people, and for us the question is, we want to spend as least time as possible to run our stuff on top of Kubernetes, right? And my question for you is, do you have experiences with services that sit on top of Kubernetes? For example, Cloud Foundry, or I think another one which does a bit less is Knative or something like this, where there's more stuff managed for you. Do you have experiences, and can you share a bit?
Yeah, that's another advantage of the modularity of Kubernetes. If you want to deal as few time as possible dealing with it, you can install a function as a service framework over your Kubernetes, like Knative, like Cloud Foundry, like OpenFaaS, and this kind of services allows your developers to concentrate themselves in writing code functions, and all the underlying logic is dealt by this function as a service framework over Kubernetes. So it's a really good approach is it's different, because then you are going to create microservices, you are going to create functions. For example, you are going to create the really the logic of your application and deploy directly this logic there. So there are many ways to do it. Knative is open source. You can install it over our Kubernetes, OpenFast too. So you have a lot of possibilities, and it can be a really good idea for small teams that want to lose as few time as possible dealing with infrastructure. Yeah.
All right, I think the next is, sorry, the next is Vikrant R. Sorry, I don't know if I'm pronouncing it right, and then Sammy will be after that. So Vikrant, yeah, thanks.
Yeah, hi, thank you. So my question is regarding monitoring and debugging applications on Kubernetes. What is your experience and any recommendations for a good monitoring solution?
Well, you can install a lot of different solutions over Kubernetes for monitoring. Many people are using Prometheus and then having some Grafana like the dashboard to monitor metrics and logs and tracing. If you want to do it in the simplest way when you are beginning with Kubernetes, I think the best solution is to install Istio, because with Istio you have the world monitoring with Prometheus and Grafana dashboard that comes with, and if you take a fresh cluster, you install Istio, everything will be monitored after that. And then if you don't want to use Istio, there are other solutions, but begin with Istio, please. Yeah.
Okay, thank you.
All right,
So,
Sammy.
I see. Oh,
maybe
okay.
maybe one more.
Yeah.
Sammy, if Sammy can ask his question, then we can maybe move back to some of the written questions. If you still got a question, Sammy. Otherwise, yeah, if you can drop your raised hand if you.
Sammy, mute. Sammy is saying in the.
Maybe I can. There we go.
Hello?
You're now unmuted.
Hello.
There we go.
Hello, Horace. So I would like to know how easy it is to integrate Airflow with Kubernetes, and what's the use of Airflow exactly, the advantage of Airflow with Kubernetes.
Airflow in Kubernetes, it is in trying to see why you would like to use Airflow on Kubernetes. Yeah, it can be done because it's a normal Apache software. I have no experience in doing it personally. I am looking in my list of projects. Yes. Let me 2 minutes. I am looking at my list of projects I have seen on Kubernetes. I think I have. It is easy to install because there is an operator for that. An operator is a Kubernetes extension explicitly done to deal with one software. Okay, there is a full documentation and full operator for dealing with Airflow on Kubernetes. So according to the feedback I have got for people who have installed it, it isn't complicated to install because all the heavy work has already been done by the community.
Okay, thank you.
You're welcome. So going back to the written question, the idea is to combine, it talks about Bitnami Kubernetes production runtime and GitLab custom CI/CD. Well, there are many runtimes for Kubernetes. We could see them like a distribution of Kubernetes. My personal opinion, and I am very opinionated on that, is to have a vanilla, a standard Kubernetes. There are many good things in different distribution of Kubernetes. We can talk about OpenShift, we can talk about Bitnami production runtime, we can talk about many of the distribution. For me personally, I prefer to keep with the vanilla Kubernetes and extending its functionality by using extensions, plugins like Istio or others, because most of the community is working in the standard open source Kubernetes. It's going to get the best support, the best error patching, the best vulnerability patching, and all that. And because if you want to use managed Kubernetes, the only thing that all managed Kubernetes guarantees you is that they are using a vanilla Kubernetes. You can deploy your GitLab CI/CD on a vanilla Kubernetes. It was one of the first use cases that our customer did, having a Word developer environment and CI/CD on Kubernetes using GitLab. So for me, I haven't seen any, in my experience, I haven't seen any real need to go to a particular distribution. I think that most 99% of the use case you can do it with a vanilla one. You said you can easily start with Istio, but it may make problems in the future. Can you elaborate? Okay, Istio does a lot of things for you. It's wonderful, but when you have a Kubernetes cluster and you have some experience, you say, hey, maybe I don't need that and that in that. And it is really complicated because Istio installs everything. It has a small overhead. If you are an experienced Kubernetes administrator, maybe you say, hey, I only need some monitoring. I can install Prometheus myself. I also need some encryption. I can install an encryption sidecar by myself. I don't need anything else. So when you are experienced, maybe, or at least some people say that they prefer to uninstall Istio and doing something really sweet to their needs. But when you are beginning, you want something that works and that protects you and makes things easy. So let's begin with Istio, and when you will be experienced, you will be able to switch Istio off and add only the individual elements you need.
We have a question from we got a verbal question
Hello.
from Benjamin.
Yeah, hello.
Hello.
Yeah, well, I have a really complicated problem. Actually, I have a patent on a compression algorithm that is extremely cluster-based, and I was asking if Kubernetes could fit to solve the problem, because we have an AI, so we have many algorithms that have to be solved, and I was asking if Kubernetes could handle a lot of quick traffic combined with multi-structured and completely flexible network systems. And we wanted to distribute anything on Azure and Google and Amazon, you know. And we tried just to have one machine in our room that is managing all the operations, but the actual clusters will be totally distributed. Is that possible with Kubernetes?
It's theoretically possible, but having Kubernetes distributed in several cloud providers, it can be done. There are some cloud providers that have product for it. I am not sure it is the best solution. And for the use case you are talking about, yes, it can be done in Kubernetes, but maybe you could try some product specifically done for that. At OVHcloud, we have a artificial intelligence product made to run TensorFlow jobs, to run, to parallelize, run on demand, and it's a TensorFlow as a service, a model running as a service. I can, if you send me an email, I can put you in contact with the people doing it. I think it will be a nice thing to try in your use case. So yes, it can be done in Kubernetes, but maybe you can find a better tool for your need. And a Kubernetes spread on several different cloud providers, you are going to have some latency problems that if you are managing big volumes, it's going to be a potential problem.
Okay, what do you call big volumes? So for me, small volumes are anything up to 10 terabyte each for each node, right? Within each operation.
It depends of what latency you consider you can accept. You can move 10 terabytes from one cloud provider to another. It's going to be really expensive in most cloud providers because I think we are one of the only one that won't make you pay for the traffic. But if you are moving terabytes around cloud providers, the problem it isn't going to be only the price. It is going to be the latency, and when are you sure that your file, your data will be at the other side and all that? So for that volume, I would like to know more before giving an advice. So please send me an email. We can maybe book a 15 minutes to discuss that in another moment because it seems an interesting use case, and I don't want to give you an advice like that without having more context.
Well, thank you. That's I really appreciate it, and I will come forward to you.
Perfect.
Yeah. Okay.
So let's see if we have other questions. Additional security recommendation or Istio will be sufficient. If you are putting your own cluster in Kubernetes, Istio won't be sufficient because you will also need to protect the underlying infrastructure. If you are using a managed Kubernetes, yes, Istio will be sufficient to be sure that non-specific attacks doesn't hurt you. If you have a very dedicated hacker that wants really to hack your specific cluster, maybe you will have some problems. But the big problem with Kubernetes is not that. It's the random script kiddie that is going to test all the open Kubernetes in the internet, and then it still will be a good solution for that if you are using a managed Kubernetes. Let's go back. It's possible to have a Kubernetes cluster to spin up more pods dynamically. Yeah, that's the idea of Kubernetes. You can say, hey, for this application, I want by default to spawn 3 pods. But if traffic, if load begins to get heavy, you can go up until 10. And you describe that. You are describing what we call a replica set, the normal value, the max value, the mean value. A Kubernetes will spawn and kill the pods in a transparent way for you. That's why the scaling of Kubernetes is really simple and very powerful. Yeah. What's the best way to restructure a monolithic Tomcat app to one using Kubernetes? Maybe the first step will be have your monolith in a container. I mean, if you have a monolith and you want to create a fully microservice application, I am sorry for you, most of the times you are going to rewrite almost everything. But you can also deploy monoliths in containers if you are able to cleanly separate data for code, and if you do some work, and then you can deploy this big container in your Kubernetes cluster. So if you have time and money, hey, go for the writing it in microservices. In many cases, simply putting it in containers is allow you to have many of the benefits of Kubernetes without having to spend that time and money to completely rewrite it. It depends if it is a legacy application or something you are going to use heavily in the future.
Actually, there's another hand up.
Okay.
Sammy, I think you've got another question that you want to.
Yeah, so Horace, I'm the one who asked you about Airflow. Actually, my main goal is I'm using the AI training on OVH to train my models.
Yeah,
And
nice.
I need a way to schedule this model and automate the process and all stuff. I need to know if Kubernetes can help with that, if the managed Kubernetes service that you have at OVH.
Yeah, I think Kubernetes, our managed Kubernetes, but Kubernetes in general can be a good idea to schedule these models in a training. Yeah, but maybe there are other solutions. Please send me an email. I am going to ask the AI training people what is their favorite solution for that. So send me an email
Okay.
after the webinar, and we will talk about it.
Thank you. I appreciate it.
You're welcome. So, I think I don't have any other question. Let me go back to the bottom. So, thank you, everybody. Would you mind sharing your deck? Of course, I think you are going to have the deck and the video of the talk, of course. So if you have another question, it's a good moment now. And if not, I think we are ending here. Thank you to everybody for being there. I hope you have liked the talk, and don't hesitate to send me an email or send me a Twitter direct message if you want to know more, or to ask Philip. He will be able to contact me and to send me your question.
As well, if you're new to OVHcloud and the startup program sounds like a good way to get involved with our products, then you can apply there. The URL on the screen, startup.ovhcloud.com. And there's also a handout there with more details about the startup program and some more use cases like the one I shared earlier. So you can download that under handouts, or just email us if you'd like to get a copy of that. But otherwise, I don't see any more hands up, and we think we've worked through all your questions. So yes, hopefully we've been able to help you on the Kubernetes journey today, and yeah, I look forward to continuing the discussion with you after this as well.